It's me again, Cikgu CharAznable. It's just past, it's just the Hari Raya day. Selamat Hari Raya to all my friends. How are you? You last year? Ah, eat biryani. Yeah. Almost Gawai already now, 12 man. Yeah. Selamat Hari Raya, Selamat Hari Gawai. Almost Gawai, Selamat Hari Raya. Alright. Oh, today we are introducing the quantum physics. Which I almost like the most. I really like the physics subject. I like to selfie sometimes the video as a hobby. Yeah. Alright. 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 What is a quantum physics? Quantum physics is a branch of physics dealing with the microscopic particle, microscopic object in the universe. Very small, like smaller than atom, like the electron. The electron is small enough. They always use the electron as a particle to describe something. Describing the electron. Quantum physics is originated from the word quanta and dealing with the very small atom object. Yeah. And quantum physics is used to make the electronic stuff like the semiconductor. Even the handphone is using the quantum technology. And electron microscope and the electron microscope using the electron to see the very small stuff like the termite something and dust. And quantum computer. Quantum computer is what is a quantum computer? It's using the electron spin upward and downward to store the data. Electron spin to store the data. Yeah, that's the quantum computer. It is very fast and can store a lot of the information very fast. Okay, today describe the birth of the quantum physics. Alright. Now the being described the trouble with the black body radiation is always talk about the beginning. You always made the black body radiation. It's just telling the story about the history of the physics. It's just telling story because science is made up of the information built up from the past. A lot of science is using this way. Using the past is kumpul the information as now you see this all as a history and can be used by the people in the future. Now it's all started with the black body radiation. Black body radiation. Black body radiation. What is a black body? Black body is like, of course, it's described as theory described it as a black subject, and a black body is a piece of material that radiates at corresponding to its temperature, like a charcoal. Charcoal is like a black body, and when you heat it up, the charcoal, the charcoal will heat up and it radiates the red light. Yeah, you know it's very hot. Yeah. And when its temperature is high, it's giving up the red light. And that's black body radiation. Alright. And how do they make it a theoretical perfect black body is using the spear with the hole, and the light and it's like it's absorbed 100% of the light and reflects nothing. Nothing as such as this as the real universe. And but this is the theoretical idealistic black body. Is the light coming out of this in this and is reflect and is reflect and it will never come out. And no light will enter the black body and radiate the black body. And this is the idealist of the black body. And you can see the spectrum of the black body. The spectrum, they analyze the spectrum of the black body. And with the spectrum light generated by the black body. Then this where the classical physics, where it's invented by the Newton, the classical physics, went wrong. Is because it's like nothing can describe. The first thing is why does light is the color of the light is so important. And is giving out energy, like is making the foil repel when you radiate the purple light, but when you radiate the other light, like the yellow light, it will no reaction. Must with purple or blue light. Yeah, and this make the physicists of the 19th century struggle to describe this. Alright, now the first attempt to describe the black body is the Wien formula. Wien formula. Is like now the U is the energy density, okay? Energy density of the emitter light is the function of the frequency and the temperature, the spectrum, okay? But this Wien formula that describe the black body, right? Wien formula used to describe the black body has the problem with the low frequency. You cannot describe the low frequency. Okay? And second attempt, this is the first attempt. Now the second attempt made by the red leg jeans. No. It's given by the alright. Where K is the Boltzmann constant. However, the red light is opposite with the first attempt where the Wien formula which is uh, work with the low frequency. Uh, Low frequency is work. This work for the high frequency. High frequency. Now work well with the low frequency. Low frequency. It's opposite. The description is opposite, right? Okay. Alright. When the higher frequency data is diverse, the higher frequency is diverse. It's called the ultraviolet catastrophe. Because the prediction, best prediction available, diverse, best prediction available is diverse at the high frequency. According to the ultraviolet light. Now this one, now is the time for the quantum physics to take over. Now it's the Max Planck. Now is what is described is very shocking. It's described that the blackbody radiation is indiscrete. Now that is the discrete theory of the Planck theory. Discrete theory of the Planck theory. Right. Now it's described that the energy of the light emitted of the wall of the blackbody cavity come out is in the integral for multiple, like the is in discrete lah, not in the continuous frequency lah. Is energy density is given like C3. Alright, the energy density is a Planck constant. It's a Planck theory given by this, and it is work well with the high frequency and the low frequency, not like the previous explanation given by the Ryan and the Rayleigh gene. It both describe the low frequency and the high frequency of the blackbody radiation. And at the end, the Planck constant is, and then calculate the Planck constant is 6.626 times 10 power at the negative 34 joules per second. Joules per second. Alright. Alright. Where this is been using, Planck constant is using in the Einstein photoelectric effect. Like he said, describing when just like I said just now, the color of the light is important than the intensity. So the color of the light changes the divergence of the two black matter. Okay. Alright. And not the intensity. It's like when you make the higher intensity with the yellow light, it doesn't change anything. If you use the purple light, change the frequency, right? E equal to HF is Einstein photoelectric effect. photoelectric effect. And now it's using the blank constant, right? Now it's the frequency that changes the repel the electron from the metal. That is the photoelectric effect. Alright! Now this is the verb of the photophysics. Finally explained by the Einstein. He get the Nobel Prize for that photoelectric effect. Alright. Thank you very much. Thank you very much. A long time I didn't do selfie. Thank you very much. My hair. That's all for the birth of the quantum physics. I just made a video for my hobby. Alright. Thank you, my friend. Thank you, my friend. I hope you are doing fine all. Thank you very much. Bye-bye. Bye-bye. Ding. Ding. You coming right now. Alright. Ding.